Okay, so combining functions. So combining functions just means that we're going to add, subtract, multiply, and divide functions. So it's really a little bit more simple than I think sometimes it looks like. I think the toughest part sometimes of these examples can be identifying the domain. So let's look at a couple examples that might give you some trouble, and then hopefully if we can explain them well, you'll have no problem at all. So let's start by defining an f of x. Let's say f of x is equal to 5x plus 1. G of x is equal to the square root of 4x plus 3. And then you could be asked to find, f plus g, f minus g. And really all of this means is f of x minus g of x. If it had been f plus g, f of x plus g of x. So we literally just sub in those function definitions. F of x is 5x plus 1. And remember, that means that is the function. Sometimes it's helpful to keep it in parentheses. Minus g of x, which is the square root of 4x plus 3. So really there's nothing to simplify here. And that's what I meant, that the algebra here is not difficult. But you're often asked to then identify the domain of this function, and that can be the trickier piece of this. So really, when I'm looking at something like this, there really is no need for those parentheses. I have something linear, and from that I'm subtracting a square root function. The linear function has a domain of all real numbers. It's just this piece that I have to worry about. So remember, when I'm looking at the domain of a square root function, all I have to concern myself with in this case is that I can't take the square root of a negative number. So whatever that number is, 4x plus 3, it has to be greater than or equal to, I can take the square root of 0, 0. And then solving this inequality will give me my domain. So 4x has to be greater than or equal to negative 3. So x has to be greater than or equal to negative 3 over 4. So as long as x is greater than or equal to negative 3 over 4, this works. So in interval notation, again, if you ever have trouble converting to interval notation, just graph it. So x has to be bigger, I'm including. So the interval notation for the domain is negative 3 over 4, comma, infinity. So let's look at another example. Sometimes the ones that can be a little bit more confusing are when you're dividing, when you're building a quotient function. So, multiplying, adding, subtracting are all going to work very similar to this. But with the quotient, we're introducing that denominator. So that takes another level to thinking about the domain. So let's say, okay, we are being asked to find, how about f over g? Okay, so again, this means f of x over g of x. So subbing in f of x, that's 5x plus 1, replacing g of x with square root of 4x plus 3. Okay, so remember the numerator can be anything, but I can't divide by 0. And now since I have a square root in the denominator, I also can't take the square root of a negative number. So in this case, in terms of restrictions, 4x plus 3 has to be greater than or equal to 0, but since it's in the denominator, it actually can't be 0 either. So to find the domain, I want to set up a strict inequality. So 4x plus 3 has to be strictly greater than 0, right? So that means 4x has to be greater than negative 3, x has to be greater than negative 3 over 4, so it does have a different domain because I have to exclude negative 3/4. All right, let's take a different f of x and g of x. So let's call this example number 2. Let's say f of x is 2 over x, and g of x is x plus 1 over x minus 1. Okay, so similarly, let's say, you're asked to find f plus g. Again, this is just replacing f with what f of x is, so 2 over x plus g of x, which is x plus 1 over x minus 1. Really, this is fine. I mean, you can certainly combine these two things by finding a common denominator, but you don't really have to. This is that function. But now when I'm being asked to identify the domain, what can't happen? Well, I can't divide by 0 in this fraction, so x can't be 0, and I can't divide by 0 in this fraction, so x also can't be 1. So those are the two numbers that I want to exclude from the domain. This would be 0, this would be 1, so those two numbers excluded shade everything else. So in interval notation, my domain is from negative infinity to 0, 0 to 1, or 1 to infinity. Now, I think it does become a little bit trickier when I look at the quotient function here. So when we say, okay, what is f over g? So f of x is 2 over x, and g of x is x plus 1 over x minus 1. So a fraction divided by a fraction. So we can simplify that, right? But consider the domain before you simplify it. Really, what's the rule? The rule is we can't divide by 0. So that means no 0 in a denominator. So take a second before you simplify this and think about where all your denominators are. I have a denominator here. So that means that denominator, which is x, can't be 0. I have a denominator here. So that you can't divide by 0, so x can't be 1. I also, this entire fraction is in a denominator. So x plus 1 over x minus 1 can't be 0 either. And what will make that fraction 0? Well, think about solving the equation. If I multiply both sides by x minus 1, they would cancel here. Anything times 0 is 0. So I have x plus 1 equals 0. So x can't be negative 1 either. So when I'm looking at this fraction x plus 1 over x minus 1, negative 1 makes this number 0. Negative 1 plus 1 is 0. 0 over negative 2 is 0. So I have 3 restrictions. All 3 of those numbers have to be omitted from the domain. And it's really easy to overlook some of those. So that's why I suggest really taking a look at every denominator in that complex fraction before you simplify anything so you can really see what you're going to need to restrict. So this would be negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity. And really, we should put our little union symbols in the middle of each of those too. Then you can simplify it. I'm not even sure that Alex will actually make you, but just to go over it, you would multiply by the reciprocal. So this would be 2 times x minus 1 over x times x plus 1. So see, if you wait till you simplify to identify the domain, we would be missing that x equals 1 exclusion that's so obvious when you look at it in complex form. So let me know if you have any questions.